Hi, good evening, everyone. Welcome back another 99x webinar series. So today I'm going to present the clean architecture, the patterns, practices, and principles. I'm Asanka Garusingha. I'm currently an associate technical architect at 99x. So today we are going to talk about these patterns, practices, and principles related to the clean architecture. Okay, so let's start. So today we are going to have few discussion points. I prepared few areas that I wanted to highlight specific areas that relates to clean architecture. The first, I'm going to give an introduction for the clean architecture and what is it and why we are using the clean architecture practices in the first place. And the second one is I'm going to talk about some of the examples related to domain-centric architecture. So the clean architecture is one of the domain-centric architectures as well. So I will give you some level of understanding what is domain-centric architecture. And we are talking about the application layer, how we are organizing our application with basically attached with the clean architecture. And then we are going to talk about the testable architecture, how to do a proper testing with the defined clean architectural practices. Yes, so you can see in this picture, you can see some kind of like layered lasagna picture is there. So you can understand why I am putting this type of image here. So it's something like we need to have some sort of an idea how we are layered our architecture without having any spaghetti code and unstructured manner. So this is basically how you are structured your code. So what is software architecture basically? The software architecture, why we are using the software architecture. So I'm here to give you some sort of an idea and sharing my experience beforehand. So basically, why we are designing a software architecture. So of course, so software architecture is a really important one. Whenever you have a requirement, basically from the user level or customer level, when you have a requirement, so you might need to consider certain level of designing of your application beforehand. Without doing any coding or any implementations, you might have to like make your design with the architecture. So it's basically the high level architecture. So you can see in the left side, I mentioned some of the areas that relates to software architecture. And the right side, you can see a diagram that everyone knows about the 3T architecture, right? So most of the developers have had most of the experience with 3T architecture, and it could be an NT architecture. Of course, they might have another layered with different set of sections, but in here you can see this is a basic pretty much of it, the 3T architecture: user interface, business logic, and data access. So this is something level of architecture that we can have most in our past development era. We have thoroughly used this type of architecture in our day-to-day applications. But in common real world scenarios and real world complexities with the application wise, the maintainability, by considering all aspects, this 3T architecture is bit of obsolete at the moment. I will talk about why is happening in that the 3T architecture. So it's basically that it's, of course, it is a structural architecture. Software architecture is basically should have the structural and the high level design, and it should have a specific layers, and these layers shouldn't be coupled each other. In certain cases, when we are developing this 3T architecture, of course, we had to have certain level of couples in between layers beforehand. But after after we are introducing the dependency inversion principle, so we are trying to get rid of lot of couples in between layers, and we are incorporate certain level of loosely coupled architecture in day-to-day developments. And there are a lot of components along with the architecture. So when you are designing a software architecture, it should have at least a set of components. Each component should have a different set of responsibilities. Across the application, there are a lot of components being shared among the layers. With the requirement level, in some cases, in modern software design, we are mainly focusing about the domain level requirements. We are not much focused about some of the specifications and some of the database level integrations. Most of the times when you are starting to design a new system, in modern software architectural practice, it's mainly related with the domain, not the databases, not the data entities, not the data sources. Then we can figure out what are the relationships inside of the software architecture. So this is the basic fundamental area that if you are selecting whatever the software architectural project, these type of areas we might need to consider. Okay, so when it comes with the abstraction, when the architectural abstraction, you can see you should have a system and you should have a subsystem within that, and layers, components, classes, and data and methods. So these are the basic items that we can integrate into the architectural pillar. So this is basically, you can see most of the things is currently are being used in our day-to-day software development practices, right? So whoever designing the system, it could be an architect, it could be a technical lead, whoever, he or she should have at least level of understanding what is the basic requirement and what are the non-functional areas that we should need to cater for designing certain architecture. Most of the times we are going with the functional requirements. Of course, that's true. We should need to have some sort of an idea to give the user to access some good system. We might need to consider the functional requirement, but other than that, non-functional requirement is really important, that like it enhance the trust in your application, and it also enhance your maintainability, and also it is enhance the reliability within the application. So basically it's really important that we should need to think about the non-functional aspects as well. So when it comes with the architectural abstraction, these things everyone should need to remember, these categories: system, subsystem, layers, component, classes, data, and methods. So this is a fundamental thing that we can get from the abstraction. Okay, now let's talk about what is clean architecture, right? So this is the definition that I can get from the internet. So basically it's actually the clean architecture is architecture that is designed for the inhabitants of the architecture. So it's something like this. When you are when you were working with the 3D architecture, most of the times you were considering about the facts, that the requirements, how you are aligned with the requirement and so on, and you are think about the feature set that you should need to provide for the users and so on. But in here, most when you are designing the clean architecture, it is not a one-time design. It's something like you are collectively gathering feedback from the users, how they are thinking about the system, and what are the experience they are getting from the system, like that. So time to time, agile based, you are developing your architecture. So basically, it's not just like a one-time design. So time to time, you might need to revamp your architecture, but this clean architecture provides that flexibility. So you can easily plug a different set of components. You can easily scale your architecture without touching the existing functionality. So it could be like you are extending your features, extending your architecture without much issues. So basically we are focusing about, we are designing, this is for the inhabitants. Inhabitants is like, inhabitants are not just the users. Inhabitants could be the developers as well. Whoever is designing or developing this system is also inhabitants. So actually, when you are designing this architecture with this clean architectural by using clean architectural practices, so of course the developers are also happy because it is really easy for them to maintain the code itself. And whenever someone is onboarded into the team, he or she can easily grab the knowledge. He or she can easily understand the code without supervision or guidance. That means that is the main thing. No one is need to behind from her or him to give the KTs on that application, because he or she can easily understand the software architecture. So that is the main thing. It's pretty clean. That's what actually I'm thinking on this. And this is not for the architect or a machine. That's true. So this is not an idea from one person. This is coming from all the feedback that everyone from everyone that given, and then with that we are designing this architecture. This is not attached with the machine or architect anyway. So it's entirely defined for the inhabitants. Inhabitants in the sense, it could be a user, it could be a developers, it could be a users who are accessing this architecture, whoever. So why you should need to invest on this? That is a really important thing. So it's basically focused on essentials. Essentials means something that it's really necessary to have in the system. So whenever you are designing a system, so most of the times you should need to think about what are the essential items, what are the essential needs. So like that, we are designing, we are mainly focusing on the essentials. So then we are thinking about some of the other specifications that you should need to add into this to enhance or to craft the architecture. So the build only what is necessary. So that is a really important thing. So only we should only think about what are the necessary things, and we should need to build around it, and we should need to optimize for the maintainability. This architecture, whoever is trying to go with the clean architecture, he always think about like another 5 years, another 10 years ahead. He or she not think about very short term period, right? The clean architecture itself is really capable to give you some sort of an flexibility and some sort of an higher maintainability to manage in the complex project, complex code. So then if you are thinking about, if you are you should need to use the clean architecture, so that means this application, that system should need to cater for another 10 years minimum, right? So think about these things. Don't apply clean architecture for every solutions that you are developing, because clean architecture won't be a suitable solution for everything, because clean architecture should have an additional level of cost, like investment cost at the upper hand, because the designing clean architecture is not much easy task, because we have to identify all the domain requirements. We might need to consider about all the abstraction levels, what are the responsibilities among components that we are developing and how we are decouple certain things. So this is a bit of upper level investment we should need to provide. But if you are invest this into the clean architecture, you will get a lot of advantage out of it. So before I'm going into much detail on the clean architectural practices or principles, so I will talk about domain-centric architecture. So domain-centric architecture, I can give you from this. So you can see in the left side, you can see a normal 3-tier architectural diagram. So you can see the 3-tier is always focuses on the data access, database centric. It is. UI layer is there, business logic layer is there. So it is always database centric, right? But in modern software development, we are not much focused about the database centric approach. We are most of the times think about the domain aspect. Database is just like a outside, it's stayed in the outside because it is something like we are using for storing or state our system data, but always we are focused on the domain. And that's why I was talking about the clean architecture itself is also think about the inhabitants in the first place. So the domain and the use case is really important. That's why the clean architecture is playing a huge role in current modern software development, because it's always considering about the user expectations. So we are in here in the right side, you can see the presentation layer, application layer, and the domain layer. Domain is the centric one, and of course the persistence and the infrastructure layer is the integrated layer that is plugged with the database or whatever the other data sources, right? So I hope now you have some sort of an idea how to differentiate the domain-centric architecture as well as the database-centric architecture. So the domain-centric architecture, there are some other examples. I hope you might have heard about these things. There are a few domain-centric architecture. The first in hexagonal architecture. If you think about the hexagonal architecture, it is also a kind of like domain-centric approach. It has the ability to plug different set of components without touching the core layer. It is also scalable architecture, and also it's handling the complex level enterprise solutions most of the times. Onion architecture is also the same. It is also connected with the domain, the customer, the project domain, and it is also have a different layers, right? So so basically it is also have a extendable functionality to plug certain varieties of components without touching anything on the code itself. But these two, hexagonal architecture and the onion architecture, is a bit of advanced architecture thing, because there are certain level of pros cons across this architecture. By addressing some of the issues that they have faced with the hexagonal and onion architecture, the clean architecture is being introduced, because the clean architecture has different set of practices that we can take specifically to maintain the software system easily, actually. So it is really easy for them to write a unit test or testable thing in the clean architecture. It's really easy. But if you think about the hexagonal or onion architecture, there are a lot of dependencies around it. So it is sometimes it is a bit of hard to understand the main domain and write the testable architecture for that. But the clean architecture is mainly focuses about these type of aspects. how to write a proper acceptance test, proper unit test for the domain-centric approach. But every architectures, these three are mainly domain-centric architectures, right? Today we are talking about the clean architecture, but if you need to grab certain additional knowledge on the hexagonal and onion architecture, please feel free to read those articles to get some idea. So why we use domain-centric architecture? So I'm giving some of the pros. So basically, why it's really important to having a domain-centric architecture. This is not only the clean architecture. This is entirely the domain-centric approach. It could be a hexagonal. It could be onion. It could be a clean architecture. It's always focuses on domain, and also the coupling is real. Less coupling is there. I'm not talking about that we are entirely remove the coupling. We cannot make that statement valid, right? We can maintain the less level of coupling, right? So we cannot get rid of all couplings. We should have at least minimum level of couplings. Otherwise, it's really otherwise it's not much practical. And also it should be a domain driven design, right? So whenever someone is asking you to develop a domain centric approach with the architecture wise, so it always focusing about the main project domain, right? If you are an architect, if you want to be an architect, right, so you should need to understand these principles. What is the domain driven design? So this is basically, it's really fundamental learning that every developers who are planning to become an architect, so he or she should need to understand the domain driven design. And there are certain level of constraints, there are certain level of practices that you should need to follow, but I am not going to talk about everything in here. But if you are talking about the domain centric approach, it's really important if you are think about different angles, like how to define certain responsibilities to cater a huge domain. There might have, it could be a complex domain, but to manage in the complex domain, you should have at least of separate set of subdomains or sub responsibilities, and design the system based on that, right? So this is one of the approach. If you are think about monolithic, it could be a monolithic approach, it could be a microservice approach. So the domain driven design is really important when it comes to the domain centric architecture, right? So now let's talk about application layer. This is where everyone should have some idea how to design the application. So that's the really important. So we, in this slide, I will share my experience, and we can talk about if you have any questions in the question and answer session. In the application layer design, so this is normal standard for four-layer architecture. Four-layer means I'm thinking about, this is also we are focusing about the domain-centric approach. So it has several set of 4 layers: presentation layer, application layer, domain layer, and the infrastructure layer. Infrastructure layer could have the persistence and infrastructure. The persistence would have certain level of interfaces to access the database. But the infrastructure layer could have certain level of other third-party services or some of the OS related services, right? Basically, it has 4 layers, right? So let's talk about how to implement the application layer, right? The first thing is implement use cases. I'm not sure how many of you following the use case diagrams, how many of you following the some of the high level user integration diagrams or anything. But if you are if you are a small developer or if you are writing a specific application logic, I think everyone should need to have some sort of an idea how to implement a use case, because it's really important when it comes with the bigger level or bigger task. If someone asks you to design an architecture for a system, so the use case diagram and the use how to mapping the use cases is really important. So this use case is the one that we are focusing on the domain layer, right? When you are, it is otherwise you cannot design a domain layer without a use case. You should have a proper use case to design the domain layer, because the use case is carried with all the need, users need, how the inhabitants are or should work with this system, right? What are the pain points that they had on the previous system? What are the new things that they should need to apply, right? So the implement use cases is really important. And then comes with the high level application logic. In my experience, most of the times I have seen that most of the developers are trying to focus on the implementation level. They are whenever someone is asked them to do a certain level of new feature development, they straight go to the code and they start to implement. But no one, it's very rare level of set of people are doing the initial design and verified with the with a lead or with the whoever the requirement has given the customer. It's very rare amount of people are doing that. So I think when it comes with the small level feature level development, I think it's really important to understand the need of having this feature. What is the main domain what is the main area that we are focusing on? If we are going with the domain-centric approach, what is the exact point that we are giving this solution for the domain? There are a lot of problems within the domain, but what type of problem that you are going to solve with this feature? So understanding the domain and understanding the user base is really important when you are writing a application logic, right? Designing high level application logic is really important. And knows about the domain, of course. I'm telling this thing, you should need to have understanding about the domain. And no knowledge of other layers. That means, right, that is something like I wanted to tell you guys. So if you are designing the architectural level aspect, you always trying to remember that how the decouple process should need to integrate. Each layer should have a different set of responsibilities, and sometimes you might need to gain the entire domain knowledge, but other layers should need to cater certain level of requirements or certain level of application requirements, and it also have a different responsibilities among that. And for adding this loosely coupled architecture, so you might need to use the interfaces to make the contract within application. So you have the contract, that means your interface, and with this contract you might implement several set of implementations. So you can use or you can plug whatever the implementations that you need to carry it out with attaching with the domain. So in that case, you can use the dependency injection, the inversion principles to cater that requirement, right? Okay. Let me talk about the testable architecture, right? This is also one of the thing that I wanted to share with you, because if I'm sharing my experience, the test-driven developments, most of the times developers are a bit of reluctant to use it, because of these issues. You can see the slide, right? The current state of testing, right? Very little testing, ineffective testing, inefficient testing, and not enough time. Not my job. It's too hard, right? So you can see these are the most of the times frequently I have seen when comes with the industry. So they are very much reluctant. They are not much deeply looking at the testing on the project because they are thinking about it's a bit of too much for them. They are thinking about it is an additional job apart from the standard developments. But in here, in the clean architecture, actually it gives a lot of flexibility. It gives a lot of easiness to add the tests beforehand. If you are developing a certain things, you can easily write to a unit test, or you can easily write to an acceptance test without getting too much of burden, right? So you cannot say that I don't have much time to add the unit test as such. Everything that you are writing in your application, so that means you are catering certain business logic in your application, try to add a small unit test or some kind of like acceptance test in your test project, that whatever that you have written is being tested, right? Should be tested in your test project with all those scenarios, right? So then you have a testable architecture, and when system grows and your code is getting bigger and bigger, when your system is getting complex to complex, so then your testable architecture is also is getting scaled up. That means you have covered almost all the scenarios in your test project. It could be an integration test, it could be a unit test, whatever, but you have been testing all the scenarios. So I am thinking like the testable architecture is really important when it comes with the clean architectural practices. Everyone should need to have some sort of an idea how to write a proper tests. So this is one of the way that I can give you. So think about the previous application layer that I have designed. Let me go to the application layer again. So you can see the presentation layer, application layer, domain, persistent, infrastructure, and there are cross-cutting concerns as well. What I mean is cross-cutting concerns means in here we are sharing certain logics or sharing certain other level of services that we can share among other layers. So it could be a date format service, it could be a extension class, or it could be a some level of encryption class or whatever. So it could be a reuse by other layers as well. So it is something like a shared layer. So that's why I'm adding this as a cross-cutting concerns. So this is if you think about this architecture, so then we can straight go to the testable architecture. So then you can see whatever the things that under the infrastructure layer and some of the dependencies, we can actually eliminate those integrations. So what I'm asking is that we can eliminate the user interface, right? So we are actually testing all the things that means under the application layer. So we have, if you are writing this as a less coupling architecture, so you probably use different interfaces, and you can mock these interfaces to do certain application logic. So that means if you are mocking certain things, so that means you are think about, okay, I'm mocking this interface, and from this method I am getting this result. This result should be returned. So I'm mocking that integration. So then based on that, I can write a testing. So as well as if you are working with the standard database, so you can eliminate the database connectivity. So you can mock the database persistence layer with the interface, and you can plug with the in-memory database, and you can get do some integration level test with that, right? And also you can eliminate the dependencies, and you can mock the certain services. Okay, if I am using this service and using this method, I will be getting this result. That is one of the mocking. So based on that result, you are completing your acceptance test. So if you are designing your architecture is if you are designing your clean architecture is much good way, that means it is easy for you to write your testing as well, right? So that is one of the things that I can give you for this. And if I straight go to the application layer, so you can see most of the times the control flow it depends. The flow is basically in top to bottom, but in some cases there are certain areas that we might have to consider some other service layer abstractions that we can use to cater in some of the few features that could come in the future. Like you can be you can use some of the design patterns or any other proper solid. You can follow solid principles, and whenever there's a new feature comes in, you shouldn't do any of the changes inside the code. You can easily extend the feature that you are getting. So then that means whenever you are designing your system, every time think about that some of the feature might come in the future. It won't be it won't happen, I'm not sure, but every time think about that you will get a new requirement in the future. So if someone is giving a new requirement, how that developer is easily plug that feature without doing too much of code changes inside your application. So when that is the really important thing that you should need to have in your mind. If you are writing your system, don't think about the outside result, that what is the result that you are providing from this class, right? Think about in addition to providing the output of the output, think about how this code can be easily maintained in the future. So then structure the code based on that. So you can use a different set of design patterns. So if I'm giving you the examples, like suppose you might have a certain logic, but it could be someone in the future, it can be extendable in different ways. So then someone is writing a decorator class. If so, this decorator class can be used for another level of operations to handle. It's a kind of like decorator pattern you can use. And also in some cases you can use certain level of creational design patterns, like factory or abstract factory. So then that means you are not going to create the instance. It's some of the factory method is doing the creation for you. So then you can easily plug different set of additional factories without touching any of the code or without touching your existing application. And also you can use some extended classes without writing a lot of if-else statement. You can grab certain logic inside the class level abstraction, and you can override certain implementations with that. So whenever there's a new requirement comes in, you don't need to add another else if statement. You can just easily create a new class and implement with the same abstract class or same interface, and you can extend the functionality. So think about that type of application design. So it is really important if you are focusing on to be an architect. So it's a really important thing to remember. So I hope now you have some sort of an idea what is this clean architecture. The clean architecture is mainly focused on the domain-centric approach. So everything that we are considering about the inhabitants that they are going to who are using in this system, and how to properly write a use cases to capture to cater certain domain areas, and everyone who is using the clean architecture must know about the domain, what type of domain that they would need to cater from this clean architecture, and how you should need to structure your application to cater certain maintainabilities in the future. Yes, I think so. These are the few things that I wanted to share. So you can ask any questions in the chat, so then I can answer if you have any questions. Okay, so far no questions. I will wait for few minutes. If you have any questions, please raise. If you need to get some sort of an like idea, so I can share my experience also. Because I was been in this for a long time, and I designed the clean architecture for my recent projects. So I can give you some sort of an hints if you need to get. Okay, I hope everyone got some idea related to the clean architecture. So if you have any questions, please raise, or we will be having another webinar in upcoming months. So stay tuned. So we'll see. Okay, I have one question. How can using design patterns help when it comes to having a clean architecture? Okay. Okay. So this is a really important thing. I really appreciate that you have asked that question. So Ishrat, right? So Ishrat, here's the thing. When it comes to the clean architecture, right? So it is really important that we should need to follow a lot of solid principles, right? The solid, I hope you might have heard about the solid principles, because all the solid principles covers a lot of fundamental of things within the code, how to structure your code, as well as how to adapt good maintainable code, right? So the solid principles is really important. By catering certain solid principles, there might have certain design patterns we might have to use, right? It could be depend with the project requirement, right? In some cases, there might have a suppose you might have a designer system for a bank, right? So in the banking system, you might need to have certain level of credit card types that you are defining in your application. So in the credit card type, you might have a different set of discount amount they are giving, right? So in that case, you will have have a separate set of like logic that you need to write, right? So in each credit card type, this is the discount amount that you are giving from this bank. But that means we cannot say that the credit card type is the static, right? So there could have a different set of credit card types will be introduced from the bank in the future, right? So that means you cannot put your logic inside the one set of class. Of course, the class itself should have a one single responsibility. That class should need to return a discount amount. That is also the responsibility. But in here, you are checking different credit card types. So I'm giving a real world example for you to then you can understand. So different set of credit card types you are defining, but whenever there's a new credit card type in introduced, you might need to modify your existing code base. That is not the way that the clean architecture suggests. Always keep the code as it is, but whenever there's a new credit card being introduced, you can easily plug. So that means every credit card types you are creating with the separate classes, and everything is being inherited from a one interface. So it could be a credit card, it could be a abstract class itself also. So there are kind of a overrideable method get discount. So every class has the override method that returning the discount amount related for the exact credit card type. So whenever there's a new credit card is being introduced, you will have another class. You can create another class without touching the existing code, and you can write a logic. What is the discount amount related to that class? So every time think about the extension, how to extend your code. And don't think about my code is getting too much of complex with adding so much of classes in the application. Don't think about it. Adding classes is not creating a complexities, but within a class, adding huge code will create a lot of troubles for rest of the other peoples to understand the logic. It's really fine to having more many classes with a small amount of code, but along with that they can understand it pretty nice. So design patterns is also giving the same thing. So this is one of the pattern that I have suggested. So someone can think about the abstract level implementation, and they could have a different set of factory classes implemented for handling or for creating the credit card amount or something like that. Or else you can create you can use some of the solid principles. That is one of the solid principles that I have been talking about. Other than the single responsibility, it is also catering the open close principle. And there are certain other varieties of practices that you could follow. Yeah, so I think this is what you need to think about when you comes with the designing, right? The solid principles, how to map the solid principles, how to use the object orientation concept thoroughly in modern software developments. And then you can find out what are the best design patterns suits. But I'm not suggesting for you to like using every design patterns that you are studying. Design patterns in the sense like we should need to understand what is the base requirement. There are certain creational patterns are there, behavioral patterns are there. So we should need to understand what would be. I hope I have given the answer for your question. Okay, then I will, I think most of you might have get some idea. So I can wrap up today's session. I think you will get another webinar series, and stay tuned. And we really would like to appreciate like if you can subscribe our channel and put a like for our channel, and write about something that you want to know, and give us some feedback. Okay, thank you very much. Stay tuned. Thank you.